A warm welcome to everybody joining us on our exciting Ekahau webinar series. Today is very special as we are going to be talking about the external Wi-Fi antennas and the search for stellar signal strength. In this Ekahau webinar, we are going to be covering everything you could possibly need to know around external Wi-Fi antennas. When to use them, why to use them, how to use them, and how to use them in some slightly non-conventional ways. So really excited to dive into this. We have got amazing Wi-Fi legend joining us on the show today, who's also a great friend of ours. So we're really excited to have him here. So I'm going to pass over to Mac so he can do a quick round of introductions, and then we can hear from the main man himself.
Totally. So thank you very much for joining, everyone. We are super thrilled to have you on our bi-weekly webinar. We are Matt and Mac from Ekahau, both directors of ECSC, Ekahau University courses and product marketing, joined by our legendary student Dale S.E.s from Americas. And the star of the show today is our good friend, Dennis Burrell from Ventev, a senior product manager. Dennis, welcome, my friend. Thank you very much for joining, for donating your time. Let's have a smashing time. And why won't you introduce yourself quickly?
Hey guys, Dennis Burrell with Ventev. So happy to be back. It's been a while since I've been on a webinar, so I'm excited to come back with you guys. I think we got some great things to talk about. You guys are going to see some awesome stuff, and it's just good to be here. I've been with Ventev for 11 years now. So, and I am the senior product manager of Wi-Fi antennas.
11 years, proper.
Wow.
Congratulations.
And I think I heard you right when you were talking to us before, Dennis. There might be a special something right at the end of the webinar that could be a new and exclusive that people might not have seen yet.
That is true. So stay tuned. Don't leave early because we're going to wow you at the end.
Okay.
So, like the guy said, we're going to talk about external antennas today, different applications, use cases, and how to do a selection of those external antennas depending on what you're trying to do, right? So, why do you need antennas? So, antennas are a central part of your Wi-Fi design, right? So basically, you keep RF where you want it. You can concentrate the RF in a desired direction. So pretty much what you're doing is you can shape your RF. And by shaping your RF, you also transversely block RF where you don't want it. This definitely comes into account when you're doing your high density designs. You want those concentrated cells, condensed cells. You want to put users on certain channels, and that's where directional antennas come in, specifically with high density. For reciprocity, you increase the ability for your client devices and APs to hear each other. With antenna reciprocity, basically what you're saying is, if I'm transmitting to you, I should be able to receive from you. Then you can increase density and aggregate throughput. And then finally, you can reduce your co-channel interference by shaping the RF. A couple of the pictures that we have there to the right is one of our high gain antennas that we have designed, and what it is it's at an auditorium where they couldn't put the antennas on a wall or anywhere, but they had these upper levels, very aesthetically pleasing design. So we were able to put them up there and shoot down to the client devices when the patrons are sitting in their seats. Next slide. So let's talk about how the RF behaves when using an antenna, right? So, excuse me, guys. RF behavior of an antenna is dependent on the type of antenna used in your design. So, right? So your omnidirectional antenna provides a 360-degree coverage pattern, which versus a directional antenna, which provides more of a directional antenna pattern, pushes the Wi-Fi or pushes the radiation pattern in a certain direction. Now, when you're pushing this radiation in a certain direction, you get these trade-offs. So When you push it in a certain direction, you decrease that beam width, the narrower or the higher the higher gain of the antenna. The higher gain means you're going in a longer direction. But conversely, if you're going in a longer direction, you're decreasing that beam width of the antenna. So let's look at a high gain antenna. Those beam widths vary between, let's say, 60 degrees and 15 degrees. More on the low gain side, we see our directional antennas somewhere between 120 degrees and 60 degrees. And as you can see by those beam widths and the gains, with the higher gain, you have the smaller beam widths, like I said earlier. Now, with omnidirectional antennas, you get that omnidirectional in your horizontal, but in your vertical, you can get different beam widths. For the high gain, you get a smaller beam width. The low gain, you get a lower beam width. Now, let's talk about that a little bit. Although it's omnidirectional, the difference between the high gain and the low gain is your coverage area in the vertical. So these antennas, if you imagine for omnidirectional, imagine a donut, right? That donut has that hole in the center. That's the same that you have with omnidirectional antennas. You have that hole under the antenna. So standing under that antenna, there's a null. The higher you put that antenna up, the larger the null is. The higher the gain of the antenna, the larger that null is under the antenna. So you have to be careful when deciding on using the omnidirectional versus a directional antenna, specifically because of those types of things and the environment. For instance, say a warehouse environment where you're going to have an antenna up 30 or 40 feet. You don't want an omnidirectional antenna in that case because of that null that I talked about, that donut shape, that hole in the donut. Next. So what are some antenna design parameters that you want to look at, right? So the design is centered around certain parameters that you use. We always talk, or we typically talk about gain and directionality, whether it's an omnidirectional or directional. But here's some other things to consider when you are looking at these antennas or looking at the type of antenna, right? So you want to look at the 3 dB beam width. The 3 dB beam width of the antenna is the peak gain of the antenna at the frequency of operation, and then you go down plus or minus 3 dB on the pattern. And that degree gives you your 3 dB beam width. And that's a typical, or that's the standard beam width that's given. So for instance, if you look on a Ventev antenna spec sheet, we'll give the beam width. That beam width is based on the standard definition of 3 dB. I know for some people that do design specifically for high density, they talk about beam width. They want to fall off of a 3 dB fall off, or at 10 dB. So 10 dB out, they want that antenna very, very condensed. So instead of looking at a 3 dB beam width, they want to look at a 10 dB beam width and want the antenna to only be down 3 dB across that whole beam width. Side lobe levels. So side lobe levels are very important in your high density design as well, right? So side lobe level is that first side lobe or outside of your main beam. The main beam is that center lobe, and then the ones on the right and left are your side lobe levels. So you want those as low as possible. Typically in some of our designs at 2.4, we want that down at least 12 dB between the main lobe and the side lobe level. And then front to back ratio. Front to back ratio is your ratio of your antenna. So we said that with directional antennas, you're steering that beam and you're pushing it in a specific direction. Kind of think of a flashlight when you turn a flashlight on and you get that concentrated beam. That's typically how a directional antenna works. But you do get some back lobe off a directional antenna. The front to back is the difference between that front lobe and that back lobe. Now, what you have to remember is the front to back ratio is calculated where the peak of the antenna on the front lobe is, and then 180 degrees out. So even if your antenna is slightly off center, say 5 degrees, you want to go 180 degrees from that 5 degrees to see what the front to back ratio is to the peak of your antenna. Next slide.
Hey, Dennis, just before we jump to the next slide, we had a really great question come into the Q&A that I feel like here could be a good point to answer it if you wouldn't mind. So the question is from Larry, and it says, how are clients able to respond to an AP that is 200 feet away, given the client device's limited TX power? We are using Cisco Marlin antennas and are surprised to find that clients can be connected at such a large distance.
Right, so that goes back to what I was talking about, right? That reciprocity theory, right? So if I'm transmitting to that client device with a higher gain antenna, even though that client device can receive it, right? Even though that client device, typically the gain in a client device antenna is 0 dBi, just based on the type of device, and since it's pretty much omnidirectional, right? Since I can hit that device from my transmit antenna, I should be able to receive from that client device.
So in simple terms, an access point that's using a high gain antenna can effectively shout louder and further in one direction, but then also they have bigger ears, so they can hear better in that same direction as well. So therefore,
Right.
being able to reach further distances and hear clients back from further distances. Thank you so much for answering that. And I will move to this slide for you now, Dennis.
Right. So the next thing we want to talk about is antenna testing, right? So testing of your antenna, or testing of a antenna. So all antennas typically should be, when you get a spec sheet and you see the patterns, those patterns can be generated two ways, right? One way is the numerical analysis of that antenna. So during the design process of the antenna, you do a numerical analysis of the antenna over the frequency band of operation. So typically that's what we do. And then we can get simulated patterns of, this is what that antenna should look like theoretically based on the design. But that's only half of the battle, right? So that's the theoretical design. Now what you want to do is you want to look at actual patterns. So you take it to an anechoic chamber, and the anechoic chamber, determines that the design specifications for the antenna are met, right? If they're not met, that means you have to go through another iteration. So basically what you see down here is a test chamber that we use for some of our antennas. And if you look at the middle one, we call it a Stargate chamber. This chamber actually has, it's a ring, and the antenna sits in the quiet zone in the middle, and it has cross-polarized antennas. Now, the advantage to this chamber that we use, as opposed to your standard far field antenna that has the transmit antenna at the end, and then in the center of the quiet zone, your antenna, is that this antenna is much this chamber that we use is much faster. So a typical chamber, you may be able to test across the Wi-Fi frequency band, maybe 2 antennas, 3 max in a day, because you got to go through all of the frequencies at each step and all of the elevation and angles. With this Stargate chamber, we could test 5 times as many antennas in a day. So on the left, this just shows the 2D pattern of the antenna, and then to the right, the 3D pattern of that same antenna. So typically on spec sheets, you'll see 2D gain patterns, but just to know, we also can do 3D 3 dB gain patterns as well. We just don't put those on our spec sheets because it's more easily to read a 2D and get the idea of what your beam width is, what your gain is, front to back ratio, and those types of things. So let's talk about when to use external antennas and the environments when they should be used. So I talked a little bit earlier about omnidirectional antennas, and at a certain height, the null below the antenna becomes too great, that null where you would lose coverage. Now, and sometimes when you go and you do your designs in Ekahau, of course you design for coverage overlap, but there's a trade-off once you get to a certain height where we recommend that you should go to a directional antenna. So for us, we say that when ceiling heights get to 25 feet or above, we recommend going to a directional antenna. When the propagation characteristics are affected by building materials or natural obstacles, such as glass in a building or brick, and there's some, we recommend directional antennas. Hallways, long corridors or aisles, or other structures with spaces in between, directional antennas, typical like a warehouse, an aisle, library with shelves, something like that, that has those data centers, more of directional antennas. Definitely for high density network deployments, large public venues, arenas, universities, specifically in their auditoriums or lecture halls, their lecture halls that hold hundreds of students. Definitely when aesthetics are important. Now, the thing with aesthetics is that, you know, a lot of customers come with the aesthetics, you know, they want Wi-Fi, but they don't want to see it, or they need to hide it, or those types of things. So this is where we can do some theming, some skinning, different types of things where we can hide the antenna in plain sight and you wouldn't know that an antenna is there. And then for improving network throughput through antenna reciprocity. See, it comes up again. So what we just discussed a little bit earlier, Matt, with the antenna reciprocity.
Exactly.
Yeah, and yeah, go on, man.
Yeah.
I was just going to say, there's almost an argument to say that there's pretty much no environment which wouldn't be a use case for using external antennas in some form of way.
Yeah,
that
totally.
is true.
So,
And
Dennis, before we continue, we have like a great question that is relevant to what we've just discussed.
okay.
Question, Osama. What is the typical use of AP with external omnidirectional antennas? Is it only if we have high ceilings? What is the recommended ceiling heights for AP with internal omnidirectional antennas compared to the external omnidirectional antennas?
So I usually say it's pretty much the same. We usually keep it at the same height, that 25 feet, but then it depends on the gain of those antennas that's internal. So typically those internal antennas are like your 3 dBi, 3 dBi type. So those are typically, you know, that 25 feet. 25 feet is kind of right on that fringe, right? So typically we'll say 25 feet, but depending how that gain is, 3 dBi, sometimes that's around 20 to 25 feet. So it just depends. Even though we know it's omnidirectional, sometimes it's not a total omnidirectional antenna, right? So it may be pseudo omni once it's internal to the AP. So there may be some areas where you don't have a total 360-degree coverage. So sometimes it'll be around 20 feet, but between that 20 and 25 feet, that's kind of where we draw the line.
Yeah, that makes sense.
Yeah,
and just to quickly add to it, if you have internal omnidirectional antenna, it's designed so it shoots slightly under the AP and around. And if you have like a rubber duck antenna, like a pole antenna, omnidirectional, then it shoots exactly around that antenna typically. And one more thing to mention here that it's not as, I don't know, easy to understand, or as commonly understood correctly, when you have low gain omnidirectional antenna, it will be like a balloon. If you have high gain omnidirectional antenna, it's like if you have squeezed the balloon, it's more like a disc. Okay.
Exactly.
And that's it.
Yep. So yeah, so that's great. So if anyone wants to do a little test or anything like that, like you said, take a balloon. When you squeeze it, you're pushing out the signal further, right? So you're increasing the gain, but you notice when you're pushing it out, that thickness decreases. So that's your beam with your vertical beam with decreasing.
And just to add, because I think there was a slight hint in the question, there was like, what would be a use case for using an access point that it supports external antennas and using external omnidirectional antennas? And some use cases where we've used them in the past is sometimes in harsher environments where you're maybe doing like a car park of a shopping center where there's going to be some harsher kind of environmental factors. Also as well, if you want to provide some external outdoor coverage, usually the external antenna parts of the antennas with the omnidirectional like rubber ducks and stuff, they're weatherproof, but the access point may not be. So you could put that indoors, drill a hole, put the cables through the wall, and then use the external antennas outside. So there's lots of different ways that you can use access points that support external antennas with omnidirectional antennas. So we are at a point now where we're going to launch a poll question. So Mac, if you would like to do the honors of just reading out the poll whilst I launch it.
Totally. So the poll is, what is the primary vertical you currently perform Wi-Fi work in? Education, government/public sector, healthcare, hospitality, industrial/manufacturing, retail, or other?
I might vote on this one.
You can? Oh, you're on your iPad, cheater.
Yeah, I joined as a guest. What am I going to pick?
I'm loving the amount of votes coming in. This is amazing, and it's really showing the focus of the audience on certain industries without giving away.
Well done,
that's good. Let me know when it finally comes out what that tally is, and then I'll see if that corresponds to what we're seeing in the industry as well.
Okay.
Yeah.
Slowing down.
I will end the poll now and
Don't
share.
end it, man. Be a good friend.
Had enough of you. There you go. So Stu may have hinted or alluded to this, but the one that kind of won by a significant amount there is the industrial or manufacturing, which I guess isn't too surprising considering our star guest today. Maybe that's pulled in a certain type of usual audience members that have got big interest in this kind of vertical, since they're probably leveraging your types of antennas a lot, Dennis.
Yep, that's where we see that use case a lot. So I agree with what we're seeing on the screen as far as polling.
So you're telling me that you wouldn't necessarily install one of your 13 dBi gain antennas into a hotel room?
No.
Okay.
Now another one on that wasn't on here that will probably do well as well is like your large public venues, right? So anytime you have a large public venue, outdoor or arena, what you're going to see is that high density design. So for the most part, you're going to see external antennas being used that way as well.
Cool. Yeah. Okay. Well,
so we have one more question. Can I interrupt?
Oh wait, we have one more poll question. Let's do the poll question and get that out the poll way. Yeah.
Okay. So the question is, how often are you using external antennas for your Wi-Fi networks? All the time, most of the time, sometimes, or hopefully not, never.
How about you, Dennis? What would you have voted for on this one?
Never. This one? I would say all the time, but that's just me being biased.
Don't worry, that's what I voted for as well, giving away a little secret there. Okay, let me end the poll and share those results. So we can see a big portion of the people on the webinar today said that they're sometimes using external antennas. Then the next biggest one was most of the time, shortly followed by never, and then all the time. So I guess that was just me and you, maybe Dennis, going for all the time.
Well, I mean, and it's indicative of the audience, and just specifically probably what we're talking about today. You got people jumping on because specifically of external antennas, and they're using them, or they want to use them, or they want to look at the different types of use cases that we're showing. So yeah, great questions, by the way.
Yeah, Mac, what was the question you wanted to ask now quickly?
I have three quick questions. Question number one that I wanted to quickly discuss is the difference in mounting internal Omni AP, or even with external antennas, on a wall versus on a ceiling. Who wants to discuss that? Wall
Sure. Yeah. So if you're mounting on a wall, is this for external antennas?
I think either.
Either.
It was most question about the internal ones, but it's applicable to both. So
for internal antennas, they won't be in the right orientation if they're mounted on the wall, just based on how they're designed, right? So they definitely want to be from a top-down type of mounting perspective, meaning on the ceiling, on a beam, or a horizontal wall mount where it comes off the wall, but it's still with the antennas pointing down.
So by horizontal wall mounts with internal omnis, you mean like a 90 degrees?
Yeah, 90 degree. Yes, exactly.
Okay. And
yes, there it is, like a T. This is your AP. This is the mount.
Yeah. So this was one of the first thing I was taught while starting focusing on Wi-Fi. Never mount APs on the wall. And then I go to Cisco office in Feltham, London Zone 6, and what I see like tons of APs mounted on the wall, like typical internal Omni APs, but they were covering the staircases, so it's fine.
And there are some use cases and some caveats, because if you're, for instance, in an office environment, you're going to get a lot of multipath, right? So you're going to get a lot of reflections of that antenna radiation pattern. So in some instances, it may work, but it's just not an optimum positioning of that AP.
Yep, very good answer. Another question number 2 out of 3. Do you know any vendor that can print or prepare skins for the antennas and access points?
Yeah. A lot of the vendors out there do skins, including us. We do skins, and we also do covers, right? So we have covers that snap over the APs to change the color.
We have them in the pictures later on, I believe. Okay, and that leads to the last question. What happens to the rec domain maximum transmitting power limits, or EIRP limits, with highly directional antennas? How do you cope with directional antennas and transmitting power levels of the radios?
That is a great question. So the FCC has a limit that they set for the maximum EIRP of the radio and the antenna combined. So if the antenna is a higher gain, once you add that antenna in, if it's above that stated limit, you have to back off the transmit power to bring it back within that FCC limit.
Yeah, and the cool thing is that you'll be able to see that in Ekahau as well. So when you're doing your designs, you can ensure for whichever country you're designing for that you're within the regulatory domains for using external antennas with the transmitting radio. So we've got some slides later on today that we can actually show you exactly where that is and how you can check to make sure you're staying within those limits. So I'll just move on to the next slide and let you continue on, Dennis.
So let's talk about external antennas in challenging environments, right? So one challenging environment, and we kind of discussed it a little bit earlier, is an aesthetic environment. So this is an environment where you don't want to see anything on the walls. It's mandated from the architects when they go through the design that they don't want to see any Wi-Fi. They want to keep the building beautiful, the interior beautiful. So what we're showing here is a couple of ways to make it aesthetically pleasing. That first one is a small form factor, what we call our small form factor line of antennas. The middle one is our floor tile antenna. This is a patented solution that we came up with, where we embedded antenna into a concrete floor tile. So now everyone is pretty much used to a top-down approach from Wi-Fi. This is what we call our bottom-up approach. We have the AP is under the floor connected to this antenna, and now we have coverage that starts from the floor up to the client device. And then that final one to the right, that picture is our junction box antenna. And that's what you see below. Our junction box antenna, we took a standard 3-gang box that everyone sees on their walls. I think it may be a different type gang box over in Europe, but in the US, this is our standard 3-gang box. And what we did was we embedded directional antenna within that junction box. So now you can put this on the wall, up or down, and then we have articulation where you can articulate the antenna and hence articulate that coverage to fine tune that precise location where you want coverage.
Awesome. So what we wanted to do is actually show you inside of Ekahau how you can configure your access points to use these amazing Ventev antennas for your predictive modeling. So what we've got here is a predictive model simulation, and we've got an access point currently configured to be using one of the external antennas from Ventev. And we can see what we're looking at here on the right hand side is when you click on the access point here, you can click on right click, edit access point, and then this is where you can alter some of the configuration settings for the access point. So what we can see here is that we've got the model of the access point plus the type of antenna. And then you can see here the mounting. So the mounting is important because this is where you can tell the Ekahau AI Pro software how you want to mount this access point. So what we've got currently set here is it is set to the ceiling. And then we can see here that we've got 2 radios. So radio 1 is set for 2.4 gigahertz and radio 2 is set for 5 gigahertz. So the important thing here to point out is that you can set the height. So if you wanted to have it at a default height of 2.4 meters, you could leave it at that. But if you wanted to change it and configure it, because maybe perhaps you've got some high warehouse ceilings that you need to install the access points and antennas at, you could change this to 5, 10, 15, whatever you needed to. And then on the right hand side here, it gives you a really nice visual of how the access point and antenna is going to be represented inside of Ekahau. And if you needed to change like the way it's directed or facing the antenna, you can just move this arrow here by left clicking and dragging it, or update this number here. And then just to come back to that EIRP conversation we was having a couple of minutes ago, what you can see here is the EIRP is actually at 16 dBm. But if you take a look at what the transmitting power of the radio is configured here on a 2.4 gigahertz radio, it's set to 8 dBm. But the EIRP is 16 dBm. So that must mean that the type of antenna we're looking at right here has a gain of around 8 dBi. So that's why it's at around 16 dBm for the EIRP. And you can see it's slightly different for the 5 gigahertz here because the 5 gigahertz is set to 14 dBm. So the EIRP is just under 22 dBm when it's factoring the Ventev antenna. So that's how you would configure it for a ceiling antenna. And I'm going to let Mac explain how you do the exact same thing, but for a wall-mounted antenna, that junction box one, just like what Dennis was explaining a second ago.
Yep, totally. So guys, the wall mounting of the antenna is very typical use case in warehouses, shooting in between the racks. Sometimes you can do that, or you can shoot from a ceiling with a different coverage pattern of the antenna. Ventev has both amazing actually. So that depends on your use case. If you want to light up an aisle with just one antenna, even if the aisle is like 200 meters long, you can mount one antenna on the ceiling and it covers entire aisle. That's awesome. If you want to have like more antennas on either side and use their maybe side and back lobes to cover the area under them and cover like a little bit more, then you can shoot 2 antennas from both sides, and that's what we'll be talking about here. So first of all, you can specify to Ekahau that you have a wall mounting, and then when you look at the radio one, you have height, and that's self-explanatory. But what isn't self-explanatory is the down tilt or up tilt of the antenna. Currently, it's in -15 degrees. That's a down tilt. So when you have a patch antenna, okay, or a sector antenna, directional antenna that looks like my trackpad, that, you know, the main coverage lobe, it shoots in the front of that plate, okay, in front. So this -15 degrees is like down tilt of the antenna. So it shoots towards the ground from the wall, okay, that's the down tilt. Now on the right-hand side, you can see an arrow around the access point, like blue access point in the middle of the screen on the right-hand side with some coverage pattern around it and the arrow around this access point. You can actually rotate that arrow in Ekahau. So that is down tilt in -15 degrees, and that is rotating the arrow, okay? And that is rotating the arrow. So that's how you manipulate directional antennas attached to the wall in Ekahau. And we had a great question to discuss a little bit more mounting options for directional antennas other than to the ceiling. So guys, very, very briefly, very quickly, without spending too much time on it. If you install the access point to the ceiling, you have like a flat bracket typically, okay? You can have different types of brackets that are thicker, that you can attach them to like a metal element in a false ceiling. But also you can attach the access point or antenna to the pole, and the pole might be sticking down from the ceiling, or it can be like L-shaped on the wall. And then you can, like, you know, attach the antenna to the L-shaped mast or a pole on the wall. So there are many, many different options. You can put an antenna in the box, or the access point and antenna in the box, or you can have a special bracket where you place the access point behind the antenna and you can mount them either on the wall or on the ceiling. If you want to look at more bracket types that are available for you to buy for different types of antennas and APs, go to Ventev website, and they have plenty of different brackets for all the use cases you can imagine.
Yes.
Mac, Jose was really liking your external antenna that you was just showing there, and wanted to know what one it was.
Oh, Apple Trackpad Generation 2, my friend. Amazing. And if you want to be an Ekahau cheater, then using both a mouse and a trackpad, that's the ultimate combo. So use mouse for clicking, like, you know, left and right, and then trackpad to zoom in and out, and 2 fingers to move around your map. You can't use Ekahau faster than that.
Okay, so the other type of antenna that Dennis was talking about that they have awesomely created is the floor tile antenna. So how would we go about configuring that in Ekahau? So what we're looking at here now is the access point in the same location, but what we have changed here is we changed the mounting from the wall to be on the floor. Okay, and then the other thing that you need to do when you change it from being on the floor is just ensure that the height gets updated to be at whatever height you're going to be actually installing. If it's not going to be quite ground level, maybe it's going to be slightly higher, you can change it here. Or if it is going to be on the ground, you could set that at 0 meters. And then you can quite clearly see now access point antenna here and the direction that it's facing. And you can see the difference in the propagation pattern from using these different types of access points, different types of antennas in different configurations. You can see how that impacts the RF. So yeah, very nice way of showing these awesome antennas here from Ventev. And a quick promotion, because for the first time we're announcing our Wi-Fi Day conference, which is the biggest wireless virtual conference of the year. So it's only just been launched today for the first time. So make sure you save your seat early, simply just by going and pulling out your smartphone and scanning that QR code, and you will be able to register for our upcoming Wi-Fi Day, which is going to be on October 5th, and you'll be able to unlock your inner Wi-Fi superhero. So you can go ahead, get registered, and you will find the full agenda and speakers will be announced very shortly. So stay tuned for that, but we're very excited. It's going to be a great event. So we hope to see you all there. And then now back over to you, Dennis.
All right. So let's talk about some external antennas in challenging environments. So what we want to talk about now is our concealed and camouflaged antennas. And basically what this is we're trying to design the antennas to fit into the environment, theme them, hide them in such a way that you don't even know that the antennas are there, and you're just trying to blend them into the surrounding environment. So that one to the left is what we call our mini bollard. And within that mini bollard, we have an AP and antenna. We have either a omnidirectional or a directional version that fits into that bollard. That sits in a flower bed. It's green foliage covered color, so you don't even know it's there. You think it's just maybe a speaker or something like that, but you're actually getting Wi-Fi coverage from it. The one in the center is our junction box antenna. And this is, as you can see, this is themed to the actual wallpaper in the store that the antenna is placed in to provide coverage. So as you zoomed in on it, you can kind of see the outline of the junction box, but it's totally themed to the wallpaper of the store.
You did such a great job, Dennis. We struggled to find it.
Yeah. These companies do great jobs hiding the antennas to the point where you have to look really close to find them. So, and then the one to the right, that's actually themed to a ride at an amusement park. That's the theming of the ride, and to the right is the directional antenna. Yep. So as you can see in these different types of environments, you have different types of things. Now, what I want to talk about right now is what we call street furniture. Street furniture is your standard lighting bollards out in the street, your light poles, and those types of things. So what we have here, all of these are Wi-Fi enabled designs. The first two are bollards. The first one is a bollard that has a light on it, and the second one is also just a bollard. Now, the interesting thing about these two, these are concrete bollards, but they have antennas embedded into the concrete to provide omnidirectional coverage from that bollard. The two on the right are actually two light poles or antennas. That one right there that's being highlighted now, typically what we did was we've just replaced the light on the top of it with omnidirectional antenna. So the omnidirectional antenna is at the top of that pole to the right. It's colored exactly as the pole. The cables go down the pole and then will come out to the access point. So just different types of way to provide Wi-Fi coverage outside. And then the final one to the right, that's a shopping mall that needed to do some coverage. They had antennas that they could put on the buildings, but they wanted to do some triangulation for location-based services so that they could push coupons to their customers as they walk by specific stores. So I don't know if you can see it, but the antennas are the little peace sign looking peace sign at the bottom of the antenna light. That's the actual antenna. Then we cable through the pole down to the bottom and come out to enclosure in the bush where the AP is. So right now we mentioned a little bit about large public venues. So when we look at large public venues, typically what we do is we look at coverage from three different perspectives. A side-to-side coverage where you can cover the aisles, cover the stands from the aisles. So this is the center aisle going down. So you got coverage from side to side. Top down, when you have a hanging facade where you can actually mount the antenna and then shoot down to the seats. And then bottom up approach is where you can place the access point and the antenna. It could be an external antenna, but it also could be AP with the internal antenna, and you place it under the seats in a NEMA rated box. You definitely want it in a NEMA rated enclosure because at these LPVs, they're always being washed down at the end of events. So let's look at some antenna visualizations with Ekahau. So we spoke a little bit earlier about the light bollard antenna. This part number is in Ekahau, and I wanted to just show how it looks. So if you look at the pattern to the left, the heat map to the left, that's the actual antenna by itself. But like I said, I mentioned earlier that this antenna was placed inside of a concrete bollard. So what the pattern to the right shows is the antenna, and what we did was we took a concrete definition from Ekahau for concrete, and we placed it around the antenna, 1 inch concrete, because that's what it surrounds the antenna once it's inside the bollard, and to show the coverage. Now, as you can see, the coverage does decrease, but you still get coverage or radiation coming through the concrete of the bollard. So this is one of those types of designs where you do want some outdoor coverage, and you know you're gonna take a hit because of what you're placing it in. But this just shows that certain designs for certain aspects of what you're looking for can be done. And then we showed earlier, this is that handrail that we showed a little bit earlier for that side-to-side coverage. With this handrail, the antenna that's in it, this handrail has the antennas back to back. So what this shows is that coverage to the right and to the left of the handrail. This has 2 APs in the handrail cabled up to 2 external antennas sitting back to back. Now, one of the things that's very important to make note of here is that, remember when I talked a little bit earlier about front to back ratio, you have to have a large front to back ratio, and I mentioned that 2 for at least 12 dB, and that 5 gig, we have at least 20 dB of front to back ratio, so you don't have bleed over from one antenna. For instance, say if that antenna is shooting to the right stands, you don't want bleed over into the left stands from the back lobe of that antenna. So you want a large front to back ratio in a design like this, so that you don't have bleed over or coverage pushing in the opposite side that you're trying to cover. And then this is that small form factor antenna that we showed a little earlier. This is the coverage of that antenna in Ekahau. Now, I know you guys see the little stubby next to it. For this design, that stubby was used for Bluetooth on the AP that was used. So that was for a Bluetooth antenna, but all of the coverage to the client devices from a Wi-Fi perspective is from that small form factor antenna, which is also in Ekahau, and this is just showing the heat map coverage of that antenna. And then finally, we have our warehouse antenna. So this is our warehouse antenna. This is a design. This is actually was provided by one of our customers that did a design in their warehouses. I think he's on this call, so thank you for sharing this with us. Now, here we go. So we're talking about a warehouse antenna. We're talking about high rack and aisles. We're talking about a lot of metal objects being placed on those aisles. So you need a narrow beam width, but you also need to cover that aisle. So on this design, those 4 APs that are kind of off center in the aisles and the one above the aisles are your warehouse antennas. Now, those other APs have omnidirectionals. They're mounted at a lower height, but you didn't have that interference from the aisles, the high rack and aisles, and the metal from that. So this is kind of a combination design where you don't have that, and you have a lower height to mount those antennas where you didn't need a directional antenna, as opposed to using the omnidirectional in those corner areas. So one of the things I wanted to show right here is that I know a lot of you guys use Ekahau, and you go to our parts and you see this long part number, and you want to figure out, well, what does all of that mean? So and these are as well on our website. So I just wanted to give you an idea of what that means, right? So if you look at that part number to the left, that M means that it's a multi-band antenna. The frequency band 6, you look down, the frequency band means it covers the 2.4 and the 5 gigahertz frequency band. Those next two sets of numbers are the gain. So for this antenna, that's a 6 dBi gain antenna on the low band, as well as a 6 dBi antenna on the high band. Now, what if this was, say, a 6.5 dBi antenna? That 060 would be 065. So that last one would be for increments of a dB that on the antenna. Then the M means that it's a MIMO antenna. The antenna type, the O, means omnidirectional. The 1 or 2 diversity, that's for when we first put that in, diversity to non-diversity, meaning this is that says it's one, it's a non-diverse antenna. The dual band leads, if there's a D there, that means it's a dual band. That means it's a 2.4 and 5 gigahertz on each band. If it wasn't, then it would be, you wouldn't have anything there, meaning that they're dedicated bands. Then you have the number of leads. Then you have the pigtail length in inches. And then finally, the connector type. And below, 02 RPTNC, 20 RPSMA, 06 in female, 07 in male. So that kind of gives you an idea of our nomenclature for how we give a part number to an antenna and how you can read that to interpret specifically what type of antenna that is and the parameters. So here's the part we was talking about, the exciting part that I wanted to introduce you guys to. So I showed a little bit earlier our small form factor micro patch antenna, excuse me, which is 4.7 by 4.7 inches. So as we've been going through our designs, we kind of want to look at how can we make our antenna smaller? What are the trade-offs that we could do to make it smaller? This definitely comes into play for aesthetics and those types of things where you want a small antenna. So our original 6 dBi antenna design was 9 inches by 9 inches. So now, as you look at our progression down to what we currently ship, which is our femto patch antenna, that's 3.4 inches by 3.4 inches. Our newest antenna, what we call our ATO Patch Antenna, is 3 inches by 3 inches. And to give you guys an idea of what that looks like, this is a 3 by 3 inch square. So this is our new design of our antenna. It'll probably be out. We're finalizing some stuff on it, but I wanted to just bring it and introduce it here to you guys first. This is a 4-lead antenna. So 4 leads coming out the back. This is a tri-band antenna, so Wi-Fi 6E capable. Excuse me. And right here, we show what this looks like in Ekahau. Matt, you want to talk about it?
Isn't it, Dennis? So you can take your ATO Patch antenna and post it via a letter, and it will fit for a letterbox. Or you can even have like a 4 in the letter, and that will still fit. Crazy.
So so this is very new and exclusive. So we have got this ATO Patch antenna from Ventev simulated in this file here. But what you would have noticed from when we were showing you the settings for editing an access point previously, we saw just the 2 radios. So radio 1 for 2.4 and then radio 2 for 5 gigahertz. But what you can see now with this ATO Patch antenna from Ventev, you actually have a 3rd radio. So radio 3, and this is for 6 gigahertz. So you can see here as well in Ekahau AI Pro, the visualization frequency that we're looking at right here is the 6 gigahertz. So it's configured to be against the wall and shooting in this direction. And we can see the coverage covering this part of the office really nicely with this type of antenna.
Yeah, and guys, like just to quickly, we are getting to the end, towards the end of the webinar. We'll take some more questions in a sec, but this is like a very quick recap. You really want to use directional antennas in your designs. It's extremely important to know how to use directional antennas, how to find them, where to find them, who to buy them from. And there is just one rule: cover what you want and don't cover what you don't want. Okay, so if you are, can you cover like the warehouse with the omnidirectional antennas? Yes, you can. You can have like antennas with, you know, the polarization going that way instead of that way, and then half of the signal will go towards the ground and half of the signal will be wasted towards the ceiling. You don't want to waste that signal. You want to direct it all towards the ground. So you have higher MCS rates, you have higher SNR, so higher this translates to higher data rates for your client, better hearing sensitivity. You really want to use directional antennas. So it's not only for the warehouse and industrial. If you have dual band networks in your offices and require a wireless first, super high density design, you want to use patch antennas and shoot down, create cones of coverage. If you cover staircases through the wall from the office side through concrete walls, you can have a patch antenna or sector antenna and shoot through the wall towards the staircase. It's possible. You can mount the antennas in multiple different locations, under the seats in the theater, under the seats in the stadium. You can mount them in the rails. And actually, when you survey an empty stadium, you will have a very high CCI, okay? But then when you have a game happening and you have tons of, you know, buttocks sitting on top of the antennas, they will attenuate. We will attenuate. We're bodies of water, and that's great, okay? So we've seen many questions about why would you use floor mount antennas, and that's because sometimes you can't run cables, sometimes it's better for aesthetics, sometimes it's easier to install, and sometimes it's just a great fit for purpose, stadiums, for example. So
Hey Matt,
please,
one second,
yeah.
one second. Yeah. We will stay on after the webinar is scheduled to finish to answer some of the amazing questions in the Q&A, but conscious that some people may have to drop now. So we just wanted to let everybody know that the next scheduled webinar is going to be on Wi-Fi in Education, the School of Wireless Wizardry. So we want to ensure we give you all plenty of opportunity to sign up. We've got another great guest joining us for this one, Troy Martin, who's one of our awesome ECSE instructors. So if you want to make sure that you are signed up for the next webinar, go ahead, scan that QR code, and you can get yourself registered for our upcoming webinar in a couple of weeks. And then we will now take quite a few questions. We'll stay on and to answer as many as possible. And then
upvote the questions that you want us to answer. You have like the upvote button in the Q&A section. So post the question or upvote the existing ones, and we'll try to smash as many as possible.
Just coming back to Dennis 1 second, because was there anything else in review that you wanted to add, Dennis? Or...
Basically that there's an antenna for the job, and selection of the proper antenna is key, especially when you're designing in challenging environments. I think we might have showed some stuff today that has some people saying, I never thought of that. So just know that sometimes thinking outside the box to get the job done is the way to go. Great webinar. Thank everyone for joining.
Oh, guys, we haven't mentioned about the very important stuff from Ventev as well. How about the PoE battery that, you know, you can use for your APO on a stick, you know, design validation surveys with APs and directional antennas? Extremely important. Do you want to talk us through very quickly about these batteries, because it's a very important part of our toolkit?
Yes, that's our Venvolt 2 battery. Very popular, specs and everything on the website. But if you're doing any types of designs, there's Stu showing it. You're doing any types of designs where you're doing walking around, this battery is the one for you. It can be taken on a plane and your luggage is TSA compliant. So that's a major plus to it as well.
Yeah, similarly to Matt, I take him on the plane with me in a luggage as well. It works pretty much every time. Okay, cool, guys.